Okay, here's your homework that you were promised. First one, do number 23. You've already done that one, but I'm going to change the directions. Assume that that's the graph of the original function, so that's y equals f of x. And then find the intervals for all of the stuff, just like we did in class at the end of the day. So f of x equals 0, greater than 0, less than 0, the derivative equal, greater and less, double derivative equal, greater and less. So find all of those intervals and give another name for each one, or either a name or kind of a description of what each one is, another way of saying it. For example, I'll give you the first one. If f of x equals 0, that's where the function crosses 0 so that would be like x-intercepts. That's where f of x equals 0. And then just kind of explain, or I don't want to explain, just a few words, whatever. What does this mean? If f of x is greater than 0, what is that? Well, I don't know if there really is one for that. Yeah, there really isn't one for these two. That's just the function is above 0, the function is below 0. But the rest, you can actually give them names. So do that. I gave you the first one. The first one's x-intercepts. See if you can figure out a name for the rest of them. So that's the first one. That's the first problem. So just look at that one and pretend it's the original. Don't write that in your book. And answer, find all those intervals. Second one is on page 264, number 70. And this is good because it's like an AP test problem. It's going to be like your first one ever that you've done. Right there, AP examination preparation. It's just like an AP problem on the AP test. So hopefully that'll get your confidence up. Don't be confused about relative max and relative minimum. That's the same as local. They're just using a different word. So those are local max, local min. And just remember, it shows the graph of the derivative. So on this one, you're looking at the graph of the derivative, and you're figuring all that stuff out. And I don't know. I'm not going to give you any hints. See if you can figure it out. Like for local maxes and mins, you're going to have to figure out what you're looking for to find the local maxes and mins. Okay? So that's your second problem. And then the third problem, and the last one, will be number 41. And this, I don't know how this is going to go. You're given the blue one is the derivative. The red one is the second derivative, and it wants you to draw a possible graph of the original that goes through that point. So use what you know about, like, I don't know if you want to do this just in your head, or for some of you it might be easy to like write some of this stuff down, or we can make a little chart like today. I don't know. To me, I just look at it and go, okay, here's my first derivative. Well, it's positive right here from here to here. So that means my slope is positive. So when I go to draw my original from here to here, whatever I draw, the slope is going to be positive. And then the slope hits 0 right here, so I'm going to go up, and then I'm going to have a hill right there. Right? And this might not actually work. I might have to like erase and adjust, but this is kind of the basics of what's happening at the beginning. Because this probably isn't going to go through point P. I didn't plan ahead. I should have probably started up here, so I might go down through point P. I don't know. So use what you know. And like here, the second derivative is negative, so it should be concave down for this whole thing. Well, isn't this concave down? It's curving, right? Pencil thing. Yep, it's concave down. And then it's going to switch to concave up at point P. I don't know. Try that out, see how it goes. that'll be funny to look at. But I think that's it. 23, answer all those and name them. Find all those intervals. Try that AP problem, and then do number 41. Can't remember if there's anything else I was going to say. Nope, I think that's it.